Alright, let's look at this question. This is all about handling imbalance. Option A says apply standard k-fold cross-validation with k set to 5. Standard k-fold may produce folds with no positive cases due to class imbalance. Incorrect. If you want the PDF version including the keyword tricks, please enroll in Diamond membership or above by clicking the join button. Please select the Diamond tab there, then proceed with it. And after you're done enrolling in membership, please do connect with me on LinkedIn at the rate of Cloud Guru Amit or Instagram at the rate of Amit Physique. I'll be happy to help you with the hands-on files as well as the PDF files. We'll move to now option B. Option B says use stratified k-fold cross-validation with k set to 5 to maintain class proportions in each fold. Stratified k-fold cross-validation with k equal to 5 preserves class distribution across folds, ensuring balanced evolution for rare disease prediction. Let's keep it. We'll move to now option C. C says use repeated k-fold cross-validation with k set to 5 and 3 repetitions to improve robustness. Repeats improve robustness but doesn't solve the imbalance issue without stratification. Wrong answer. We'll move to option D. D says split the dataset into 80% training and 20% validation using a stratified sampling method. Single stratified split lacks the robustness of multiple folds for model evolution. We'll delete this. We'll lock option B as the right answer. Alright, now let's look at this question. Option A says convert all shelf images to grayscale and retrain the model using the same dataset. Grayscale conversion reduces feature richness and may worsen model accuracy, hence incorrect. We'll now move to option B. B says limit the item class to 3 instead of 11, build the model and refine it incrementally. Reducing item classes avoids the core problem and limits model usefulness. We'll delete it. We'll now move to option C. C says physically tag each item with colored labels, recapture the shelf images and retrain the model. Adding colored labels alters the natural appearance and may not reflect real world shelf conditions. Wrong answer. We'll move to now option D. D says apply image augmentation techniques such as flipping, rotation, translation to expand the dataset and retain the model iteratively. Image augmentation with retraining increases dataset diversity and improves generalization without requiring new data collection. Therefore, option D is the right answer. Okay, now let's look at this question. This is all about improving systems accuracy. Option A says deploy the model to SageMaker notebook and apply SageMaker's hyperparameter tuning feature to refine the configuration. Hyperparameter tuning has already been exhausted and won't overcome data limitations. Incorrect. We'll move to now option B. This is expand the training dataset and retrain the model using transfer learning to reduce model bias. Expanding training dataset and retraining with transfer learning increases data volume, helping reduce bias and improving model accuracy. Let's keep it. We'll move to C. C says switch to a deeper neural network pre-trained on ImageNet and apply transfer learning to increase model complexity. Increasing model depth may raise variance without solving the bias issue caused by limited data. Wrong choice. We'll move to D. D says retrain the model using the current architecture without modifying the dataset or configuration. Retraining without changes won't improve accuracy, but accuracy due to the current data and bias constraints. We'll delete this. We'll lock option B as the right answer. Alrighty, we have a multiple choice question. We need to select 3 correct answers. Option A says choose a higher number of layers. Increasing layers worsens overfitting and reduces test accuracy. Hence incorrect. We'll move to B. B says choose a lower number of layers. Reducing layers lowers model complexity and helps mitigate overfitting. Let's keep it. We'll move to C. C says enable early stopping. Early stopping stops training when validation performs stagnates, improving generalization. Let's keep this. We'll move to D. D says enable dropout. Dropout randomly deactivates neurons during training to reduce overfitting. That being said, option B, C, and D are the right answers. Alrighty, we have a brainstorming question. Option A says visualize feature distributions and calculate standard deviation. Drop features with high variance. High variance may indicate strong predictive power, not irrelevance. Incorrect. We'll move to B. B says visualize feature distributions and calculate standard deviation. Draw features with low variance. Low variance may indicate limited information but doesn't confirm lack of predictive value. We'll eliminate it. We'll move to now C. C says generate a heat map of feature to feature correlations and remove those with weak mutual relationship. Mutual correlation between features doesn't reveal their relationship with the target variable. Wrong answer. We'll move to now D. Option D says evaluate correlation between each feature and the target variable. Remove those with weak correlation to sale price. Correlation checks against target variable, removing features that contribute little to predicting sale price, improving model variance, improving model relevance. We'll keep it and lock it as the right answer. Alright, now let's look at this question. We'll look at first option A. Option A says label the dataset with future fault occurrences to frame it as a supervised learning task. Train a recurrent neural network to detect fault patterns over time. RNN captures temporal dependencies in sensor sequences, enabling early fault prediction. Let's keep it. We'll move to B. B says apply an unsupervised clustering method using Amazon SageMaker key means to group similar sensor patterns. Unsupervised clustering doesn't provide fault prediction or temporal forecasting. Incorrect. We'll move to now option C. C says label the dataset with feature fault occurrences and train a convolutional neural network to identify fault signatures. CNNs lack sequential memory, making them unsuitable for time-dependent sensor data. Wrong answer. We'll move to D. D says use Amazon SageMaker sequence to sequence to model the time series data for fault prediction. Sequence to sequence models are designed for sequence to sequence tasks like translation, not fault classification. Wrong answer. We'll lock option A as the correct choice. Alright, now let's look at this question. We'll first look at option A. It says master node. Master node manages cluster coordination and should remain uninterrupted to avoid failure. Incorrect. We'll move to B. B says any of the core nodes. Core nodes store HDFS data, and interruption from spot instances risk data loss and job disruption. Wrong answer. We'll move to C. C says any of the task node. Task nodes handle transient compute and can be interrupted without affecting cluster integrity, making them ideal for spot usage. We'll keep this. We'll move to D. D says both core and task nodes. Using spot instances for core nodes compromises data durability, and cluster reliability. We'll reject it. We'll lock option C, any of the task node, as the right answer. Okay, now let's look at this question. Option A, if we look, TSNE reduces high dimensional data to 3D or 2D for fast visual inspection of natural clusters using scatter plots. We'll keep it. Now let's move to option B. Option B, if you look, elbow plot helps determine cluster count but doesn't provide immediate visual grouping of customers. Wrong answer. We'll move to C. C says apply TSNE to the numerical features and generate a line graph to visualize the embeddings. Line graphs are unsuitable for visualizing embedded high dimensional data. Let's delete it. We'll now move to option D. D says run k-means clustering using the Euclidean distance metric and generate box plots for each numerical feature within each cluster. Box plots offer statistical summaries but are slower and less intuitive for initial cluster visualization. Wrong answer. We'll lock option E as the correct choice. Alright, now we got multiple choice question. This time we need to select two correct answers. Option A says precision and recall. Precision and recall measure classification quality for imbalanced outcomes. Let's keep it. We'll move to B. B says root mean square error, RMSE, and mean absolute percentage error, MAP. RMSE and MAP are regression matrix, not suitable for binary classification, what we have in the question. Wrong answer. I'll move to C. C says accuracy and F1 score. Accuracy and F1 score provide a balanced view of prediction correctness. Therefore, another correct answer. Now let's move to D. D says bilingual evolution understudy, that is BLUE score. BLUE score is used for evaluating text generation, not classification task as asked by the question. Option D is wrong. We'll lock option A, precision and recall, and option C, accuracy and F1 score, as the right answers. Alrighty, we got another multiple choice question. We need to select two correct answers. Option A says cross validation. Cross validation is used for model evolution, not for feature transformation. Incorrect. We'll move to B. B says numerical value binning. Binning simplifies skewed distributions by grouping values into ranges. Let's keep it. We'll move to C. C says high degree polynomial transformation. High degree polynomial transformation increases variance and complexity, worsening skew correction. Let's delete it. We'll move to D. D says logarithmic transformation. Log transformation compresses large values and reduces right skew. Therefore, run the correct answer. We'll lock option B, numerical value binning, and option D, logarithmic transformation, as the right choice. So if you want the PDF version including the keyword tricks, please enroll in Diamond membership or above by clicking the join button. Please select the Diamond tab there, then proceed with it. And after you're done enrolling in membership, please do connect with me on LinkedIn at the rate of Cloud Guru Amit or Instagram at the rate of Amit Physique. I'll be happy to help you with the hands-on files as well as the PDF files.